Hi everyone. So this is regarding the question which came in the group, which is why is overfitting bad? So I'll start with like zero. So this might be a long video. So here is the thing. So I hope so. This is our basic mathematics. For an x and y, there is a point A. So for a two-dimensional space, the value of A is given by only x and y. There is no third factor, there is no fourth factor, there is no any factor which could help determining the value of A or could influence the value of A. There are only two values. So the value of A can be 2x plus y, it can be 3x plus 3y, anything. Point is, depending on x and y, the value will change. Likewise, in a three-dimensional space, the value of point A is given by x, y, and z. So this is the really simple, I would say, the most simple space in which you can imagine the value of a point or a problem. Coming to our day-to-day life. So what we do in data science is basically we find a solution to our day-to-day problems. So unluckily, I would say our day-to-day problems, obviously, I mean, anything which happens because something happened. There is a chain effect. So uh, unfortunately, the thing is, our day-to-day problems or the issue what we want to identify, we never have the full data set to identify a problem. For example, there is a problem. I would say, let's say, earthquake. Probability, we have to predict whether the earthquake will come in a particular region or not, depending on various factors. Let's say one factor is position of tectonic plates. Second factor is you can say climate. I'm not sure if that plays an important part or not. Third factor is construction. So likewise, there are various factors. Now the thing is, the space in which we live, the problems which we have, we never have a full set of factors which would actually result in an earthquake. We never have. So whatever problem we have, our day-to-day life problem which we try to solve it to data science, we never have a full all the dimensions possible which could uh, predict or which could result into that dependent variable. Now let's say this is x, this is y, this is z, and there is a set of uh, x, big X, this is small x. So there is a set of factors which we don't know yet. Now had this been a mathematical problem, because see, data science is nothing but a mathematics of unlimited dimensions. That's what data science is. So our main effort is, so for example, let's say to predict an earthquake, the role of a position of tectonic plates is, let's say, a big role, let's say twice. Then the role of climate is, let's say, less than, so let's say single. Then the role of construction is, let's say, big, let's say 5 times z. This results in an earthquake. Okay. Now point is, had we known all the possible dimensions, all the possible factors which leads to an earthquake, let's say this is the full equation of earthquake, like a, b, c are those factors which we don't know, x, y, z are the factors which we know, and this is the weightage of each, let's say 4, 8 and 3. So if we know all the things, then we would not predict, we would calculate. That's the difference between calculation and prediction. In calculation, you know everything and then you calculate. In prediction, you know half of the stuff and just predict if it is going to happen or not. So since we don't know this stuff, we just have this. In an overfitting model, in order to compensate for these values, the weightage of these parameters is going to, let's say, increase. So in order to compensate for these values, let's say x becomes 5x, y becomes, let's say, more than this, more than x, so let's say it becomes 7y, and let's say this become 3z, and that results in a, so this is an overfitted model. Overfitted mod in what happens in overfitted model is the dimensions which we know is going to compensate for the dimensions which we don't know, resulting giving you an actual solution. So in overfitting model will look something like this. So overfitted model is a this mathematical calculation. Now what this means is that if and from this weightage, what data scientists or the what business guys would do, they would think, okay, fine, so climate is playing the most major role because its weightage is most, and then after that the tectonic plates position, and then the construction. But in actually the construction role is the most. So let's say this is so this is playing this is the most important factor in an overfitted model, but in actually the most important factor, uh, hypothetically, if we know everything, is construction, then tectonic plates. So here the most important factor is climate, because it's an overfitted model. Now our aim of creating the model is whatever we know, we are able to get the right weightage. Had there been the you can say, had there been most had there been an ideal scenario, we should be able to get the right weightage of the factors what we know. That's why we do not overfit. We just generalize the model in such a way that overfitted model will look like this. A generalized model will look like this: 0.5y plus, let's say, 3z. This generalized model is not going to give you exact earthquake at every time, but at least we know that the most important factor is played by construction, which matches the actual equation of the earthquake, then tectonic plates, then climate. This weightage might not exactly be equal to this, but they should be in the right proportions. That is the reason we never overfit the model. Underfit the model, again, if we are going to underfit the model, this might actually become x plus y is equal to e. Underfitting the model means whatever we have, we are ignoring that also. So underfitting is that. This is your overfitting. Overfitting is giving you the exact equation with what we have. Underfitting is ignoring what we have, and good fit or actual fit is actually giving you the right weightage of the dimensions what we have in proportion to the equation of the actual event had we known all the dimensions. I know this might sound a bit tricky, but that is how it is. Thanks guys, let me know if you have any issues. I'm just going to put in the full cover here so that you guys get everything, this whole thing. And okay, thanks, bye bye.